Hello everyone, and welcome to this talk about property resident initiated flood zone removals in the United States National Flood Insurance Program. My name is Devin, and this talk is being recorded as part of the Kasperson Award Series for AAG 2020. So there are at least 3 areas of research that have inspired the project I'm going to talk to you about today. And you can see them listed here. So metrics and to study vulnerability to environmental hazards, access or inequalities to access to flood hazard protection, and knowledge production around flood hazard stemming out of more recent ideas as well, like critical physical geography, which has really been a big inspiration and driven me towards this present project. But what I want to work on and argue today is arguing that really putting those pieces together hasn't happened before, so that geographers have been under-attended to examining these links between kind of predicting flood hazard and then how in turn that knowledge impacts vulnerability. And I want to use the National Flood Insurance Program to study this, but also because of some societal benefits I think that we can examine tied to this. So if you're not familiar, in the National Flood Insurance Program, flood insurance rate maps, so flood maps, are used to set insurance premiums and are revised over time by technical experts, so people like engineers and hydrologists. And specifically on this talk, we'll focus in on these flood zones known as special flood hazard areas, or this area of 1% or greater chance of flooding annually, based on kind of the historical observations used to predict those flood zones. And these are the highest flood zones on flood insurance rate maps. So here's an example. So over on the right hand side here we can see the light blue are all the special flood hazard areas for the state of Florida, which we'll be examining in this talk. And I just want to note here that these special flood hazard areas also have kind of several sub-flood zones to them that make up them, but and those are really determined by how intensive of a study or what kind of methods for the studies, what hydrological and hydraulic methods were used, and that will become important. I'll kind of come back around to that at the end of the talk, but for now we'll just focus on just the special flood hazard area. So property residents, so what I'll term these people who live in these special flood hazard areas, can also, once these maps are set, can also hire independent technical experts to essentially review these flood studies and attempt to provide some sort of new data that shows that their property actually should be outside of the special flood hazard area. So they go from being inside to being outside. And I'll show you this map again later on, but really this is a much zoomed in version of that prior map on the last slide, where now once again we have the blue of the special flood hazard area, but we also can see the individual buildings, individual tax lots, and these dots, these 2 black dots that are showing approved appeals in this case for these individual properties, which are known as letters of map amendment, which is what we'll be looking at in this presentation. Because we can assume that property residents pursue letters of map amendment because having a property moved outside the special flood hazard area means that they will pay lower insurance premiums for essentially the same coverage of damages in the event of a flood. And there's anecdotal evidence to suggest, so basically some news articles I'm drawing upon, that have suggested that really it's the wealthy who are taking advantage of this, that it's the wealthy who are able to remove themselves from the special flood hazard area, and those who really do not have the socioeconomic means are not able to do that. But there hasn't been any real analysis of this, and I would argue that this is important to study because we could think that inequality will be exacerbated if socioeconomically advantaged property owners really can remove their properties out more often, because in the long term that means they're also putting less money into the program through insurance premiums, while the more marginalized are either unable to remove themselves out, so they're paying more insurance premiums, or they may forego insurance more often. So the research questions that drive this are twofold. We have, what is simply the spatial distribution of successful lomas in Florida, and then what is the relationship between specifically successful residential lomas in Florida and socioeconomic variables at both the individual property and census tract scales. And so there's a number of data sets that I'm using here. A lot of some of the Florida data coming from the U.S. Census Bureau and FEMA's Map Service Center website, but also specifically just GIS buildings coming from a Microsoft Open Access or Open Data Layer, and then the tax lots coming from Florida Department of Revenue and American Community Survey data from American Fact Finder. All this data is out there and freely available, and I compiled it to conduct this research. So I'm going to walk you through the methods here. For question 1, part of the reason I chose Florida to show here is because about 1/3 of all national flood insurance policies are in Florida, and so it also kind of then follows that there's also going to be a lot of letters of map amendment. And so what I'm going to assume here is kind of a null hypothesis, or just have this assumption that LOMA distribution is going to be weighted by the number of buildings in the special flood hazard area per Florida census tract. So essentially, if we spread them out evenly as kind of distributed by the number of buildings that are in the special flood hazard area, how close does that actually match up to observed is the question I'm kind of asking here to determine a spatial distribution. So just simply I'm summing the count of all LOMAs and the count of all buildings in special flood hazard area across all the census tracts, then dividing the former by the latter to get a ratio, which I multiply by the number of buildings in each census tract, so the total number of buildings in each census tract, to calculate predicted LOMAs, and then essentially just then I'm subtracting the observed minus the predicted to get a residual, just figure out, okay, how close was the observation to this weighted prediction that we might expect. But Florida is also used because there's this statewide GIS property scale data set from the Florida Department of Revenue. So I'm working on doing this at a statewide scale, but I'm just going to show you a county case study in this example. So I'm going to focus in on Palm Beach County, which is highlighted here on the right. So as we start zooming in, we can start seeing more of the census tracts. We can see the density of them over here on the east side mainly of Palm Beach County there. And we continue to zoom in. We can start seeing more individual census tracts here, and then we can just start layering on those other layers. So here we bring back in that special flood hazard area in the blue, and then back also with the buildings and the individual tax lots here. And again, our letters of map amendment. So for question 2, what I did was essentially pulling out the property values that are tied to these individual tracts, individual to the individual tax lots. The census tracts here are shown in the black outlines. And so for the individual tax lots, essentially pulling out the property values for properties that had LOMAs and comparing those to all properties that were in the special flood hazard area, and comparing those two distributions to properties that were outside of the special flood hazard area. So looking at those three kind of side by side, seeing the differences of the distribution of those values. So to show some of the results, here we have question 1 results. So again, by census tract, this image is showing us that difference between the observed LOMAs minus the predicted LOMAs, so this residuals. So we have negative values, or these blue tones, the darkest being the largest negative values, where those are having much fewer observed LOMAs than predicted. So meaning there's a lot of buildings in the special flood hazard area, but very few LOMAs relatively. And then kind of the opposite of that, we have positive values, the greatest positive values, where we have higher observed LOMAs than we would expect. So meaning there's relatively a lot of LOMAs compared to the number of buildings that were in the special flood hazard area for these places. So we see that there's a variety of patterns here, but one that I want to point out most frequently is much along the coast in many areas. I found that there were generally negative values, some of them moderate, some of them larger. compared to generally more larger positive values, often falling inland. And so we're seeing that in this example here for South Florida, but the pattern generally also holds as we moved into Central Florida here as well. With this example, again, we look at the coast, generally about 0 or negative values in many places, where inland there was generally, again, around 0 values or positive values. Again, there are exceptions to those cases, but generally you see that pattern in many places. Then to research question 2, just to do a little bit of data exploration. So this is for all the census tracts in the state of Florida. Again, we're taking that residual LOMAs and comparing it here to some socioeconomic characteristics. So median income increasing from left to right here. And we see some of the highest positive values, those ones that really, those outliers that stick out the most, kind of falling in the middle of our value spectrum. Otherwise, everything kind of falling down here. Again, a lot of the biggest changes in the kind of the middle of all of our values possible for the median income across these census tracts. Percent poverty comparison here now, and we see some of those largest positive values were at relatively low amounts of percent poverty, but again, in this large aggregation of everything together, we're not seeing any strong trends. But I at least want to focus in then to show on the individual property scale. Again, I just have this one case study example for Palm Beach County, and so I'm working on seeing if this is true across the state. But one thing I found interesting, I'm going to pull out here, is when examining just the LOMAs, the property values of the LOMAs here on this left-hand side of this table, compared to all property values for all properties that were in the special flood hazard area versus all that were outside the special flood hazard area, now on the right-hand side, we can see that actually when we're comparing these quartiles, so first quartile to median to third quartile, we see a lot higher values for the LOMAs falling here compared to properties that were either inside or outside that didn't have LOMAs. And similarly, when we now standardize, we have this percentile of LOMA property values, essentially taking that out of the property value distribution of all properties in the special flood hazard area. We're seeing that most of this falls in the about 40 to 70% percentiles here. So again, not much lower and not much higher. And so I just want to wrap up these next couple of minutes talking about some of the again, some hypotheses what might be causing these distributions. And I'm also going to be conducting interviews with some FEMA officials, from engineers, hydrologists, the people who actually approve these changes, to also be building upon these results that I'll be working towards. But in terms of that spatial distribution, there's kind of this question is, well, are the coastal areas simply just more difficult to remove from the special flood hazard area because of the physical processes going on there? Or is this that there's certain types of flood zones that are easier to change for flood hazard prediction? Or even that, there was a certain types of different sub-flood zones, so is it something that has to do with those? Or even that there are different types of LOMAs also that occur, so some of them just, using changes in the hydrology or hydraulic data, though some of them rely on actual physical topography change and bringing in fill dirt. So is that an impact? That all actually still needs to be worked out more, and I can talk more about that in our Q&A session. But also, for question 2, so LOMAs, are they being more accessed actually mostly by properties in the middle of that value spectrum? I guess taking property value there as kind of a proxy, and so that kind of is compared to an idea like facilitation, where it's always the most wealthy, or it's frequently the most wealthy who are kind of facilitating, using social protections or kind of to keep themselves in hazardous places. Is it more that these middle area are getting more bang for their buck, or is it that we have or will that vary geographically as I actually move around the state of Florida and see who's residing in the special flood hazard area? So I just want to show you very quickly my my references here, And thank you for watching, and hopefully looking forward to having a good Q&A session with all of you on Monday. Thanks.